Hello, so today we will be discussing about graphing parabolas using this equation. So our equation is x minus 4 quantity squared is equal to 16 y plus 2. First, we're going to identify the vertex, so you just use the transpose and additive property will give us 4 and negative 2 based on the x and y values. Next, we will be identifying if a parabola opens upward or downward. So that would be just by identifying the value of 4p. So 4p here is positive. And what is the equation that is quantity squared? That is the x equation. So note that if it is the y equation that is quantity squared, the parabola could either open left or right depending on the sign of the value of the 4p. Whereas if it is x that is quantity squared, it could either open up or down depending on the sign of 4p. So 4p here is positive, and the quantity squared equation is x. So that would mean the parabola opens up. I hope you understood that part. Next, we're going to discuss the focus. So in order to know the focus, we have to divide 4p, which is equal to 16, divided by 4 to cancel it out, to get our value, which is equals to 4. So the value of p is 4. P will help us determine the value of our focus and how many units we have to move upward. Because remember, when you move upward, when your parabola opens upward, the focus is above the vertex. Downward, the focus is below the vertex. Leftward, the focus is further left of the vertex, and rightward, the focus is further right of the vertex. Whereas the directrix, if your parabola opens up, the directrix is below the vertex. Down, it is above the vertex. Left, it is at the right of the vertex. And right, it is at the left of the vertex. Take note of that. Let's plot our focus. So since our value is 4 here, let's go and identify a bunch of things. Okay. So first, we're going to go to the vertex. The vertex is 4, negative 2, which brings this over here. Let's think that it's perfect, Let's just say that maybe it is stuff. And let's move upward 4 units up. Okay. This will be negative 1, 0, 1, 2, 3. So, negative 1, 0, 1, and 2. So this will be 4 and positive 2. Our focus is 4 and positive 2. That's it. Next, we're going to identify the directrix by moving 4 units down, and that will lead us to negative 6. So this is our directrix. And since the linear equation here is y, the linear equation will always determine our directrix. So that would be y is equal to negative 6 directrix. For the axis of symmetry, it will simply be at the middle of the vertex, and that would become x is equal to 4. So that's the x-axis of symmetry. Next, we're going to identify the endpoints, which is only identified if we divide the latus rectum over here, the value of the latus rectum by 2, which is equal to 8. So 8 each side. So let's go. This will become positive 3, 2, 1, 0, negative 1, 2, 3. 4. So that's negative 4 over here. And sorry, that's a bit too high. This is negative 4 over here. So our endpoint over here at the left is negative 4 and positive 2. And at the right, it will become positive 12 and positive 2. So supposing this is already positive 12 because it can't really fit anymore, let's just suppose it is. It will now become an upward opening parabola. So we've got it, folks. This is our parabola. We have all the values here, and we completed the solution. Hope this helped.